quickly move on to question number 9. So this is question number 9. Again, this is somebody who also emailed saying that they were struggling with this particular question. So question number 9 will be tackled in a very similar way. So let's have a quick read. It says at time t seconds, the velocity of the particle is given by the following. So we'll jot that down straight away. So for part A, we're told the velocity in terms of t. To be honest with you, a lot of the time you will actually find in a lot of these sort of questions, they will normally tell you what velocity is, but not always. Okay. When t is 0, p is at the origin. That's a condition that we're going to use within the question, so that's another important part of the question. Find the value of t when p is again at the origin. So let's try to understand what this question is really asking for. So over time, this particle is going to be moving away from the origin. But there's going to be a certain point when the particle is actually going to head back towards the origin. So what this question is asking for is to work out the value of t for when the particle is going to be back at the origin. So if we want to work out the value of t for when the particle is going to be back at the origin, we need to understand that the overall displacement is going to be 0. Okay, so when the particle is back again at 0, it means the displacement is going to be equal to 0. So in this case, we need to work out an expression for displacement. Let's go back to the top over here again. To work out displacement from velocity, we need to integrate. So we're going to do the exact same thing again. So we're going to integrate velocity. So we'll say displacement equals the integral of the velocity in terms of t dt with respect to t. And let's integrate, let's see what happens. So here we're going to say, well, displacement, so we'll say x is equal to, so rules of integration, remember, you're going to add 1 to the power and divide by the new power. So here we'll get 3t cube divided by 3. So that cancels down to simply just t cube minus 12t squared divided by 2. That becomes 6t squared. Integrating a constant, we'll get 5t, and then we'll have our constant of integration, which we're going to call capital C. So again in the question, we've been told when t is 0, the particle is at the origin. So that's our initial conditions. So we can substitute t is 0, x to be 0, and by doing so, given the initial conditions, we're going to find that c is actually going to be equal to 0, like before in that previous question. So therefore we can say x will be equal to t cube minus 6t squared plus 5t plus 0, which in other words, just this. So find the values of t for when the particle is again at the origin. Well, when it's again at the origin, overall displacement is going to be 0. So if the displacement is equal to 0, then what does that mean? It means that our equation for displacement would become 0 equals t cube minus 6t squared plus 5t. So this is a cubic equation. What's common? T is common to all three terms, so we can factor out the t, and as a result of that we end up with a factor t squared minus 6t plus 5. That quadratic factor can be further factorized, so this becomes t minus 5, t minus 1, and solving you get the following values for t. So we can say, well, therefore t is going to be equal to 0, t is equal to 5, and t is equal to 1. So find the values of t But when the particle is going to be again at O, well, that's going to be when t is equal to 5 and t is going to be at 1. So that's the answer to part A of the question. Part B of the question. Find the distance travelled by the particle in the interval 2 to 3 seconds. So, again, we might want to go ahead and draw a little picture of this so that we can try to make sense of which part of the graph we're actually looking at trying to calculate. So let me just quickly copy that down again. So we've got a graph of V against T. So if it's a V against T graph, this is our V, which is 3t squared. That's positive, so we know it's going to be a U-shaped graph. The intercept is at 5. So we're going to say the graph is up here somewhere. So this is 5. Will it cross the x-axis? Will it cross the axes? One way to know for sure is you can calculate the discriminant. And if you calculate the discriminant, b squared minus 4ac, what's that? 144 minus, so that one would be positive, so therefore we would actually get 2 roots. So let's go ahead and draw this. It doesn't really matter what the roots are, to be perfectly honest. Okay, but you're going to end up with a graph that's going to look very similar to the following. Okay, so that's basically your quadratic graph. Now remember, this is in context, so as you can see over here, I haven't, on the left hand side, I've started the graph at 5 along the y-axis. Okay, so this is the part of the graph that you only need to draw. Now we're interested in calculating the value of the distance travelled in the interval 2 to 3 seconds. Now if you do calculate what those roots are using your calculator, I think I've got 3.52. So 2 to 3 seconds would be somewhere here. So let's just mark that in. Okay. So this is basically the region that we're trying to calculate. So this is when t is equal to 2, and this is when t is equal to 3. So this is an area that's under the x-axis or the t-axis. So in other words, when we start calculating this area, we should end up with a negative result, of which we will then take the magnitude of that answer. So how do we calculate this area? Well, we will calculate this area by integrating the velocity function in terms of t, which we did in part A, and we're going to use this result. So this result over here, we're going to use that to help us determine what this area under the t-axis is. Now the limits are going to be 2 and 3. So if I write it out in the following way, we're going to say, well, x is going to be found by integrating the velocity function with respect to t between t is 2 and t is 3. Well, we know what the result of that integral was. That was t cubed minus 6t squared plus 5t. Only now is we're just going to introduce the square brackets, put your limits in, 2 and 3, and we're going to substitute. So let's go ahead and substitute. So we're going to say, well, x is going to be equal to, curly bracket, 3 cubed minus 6 lots of 3 squared plus 5 lots of 3. That's the upper limits gone in, and we'll take away open curly brackets again, and the lower limit gets plugged in. 2 cubed minus 6 lots of 2 squared plus 5 lots of 2. And when you put this all into your calculator, when you calculate it, you end up with, what do we get? You end up with minus 12. So this is minus 12. Take away negative 6. And minus 12 take away negative 6 gives you minus 6 meters. Well, it's definitely negative, and that corresponds to the fact that the region that we've just calculated is under the t-axis, but the question is saying calculate the distance travelled. Distance is a scalar quantity, so we can take the magnitude of this answer, and we can therefore say, well, therefore the distance travelled is equal to 6 meters. And again, similar to question 7 that we did, we drew a picture. Picture really does help when it comes to tackling problems to do with variable acceleration. This one wasn't too difficult in comparison to question 7. 7 involved 2 regions, one above and one below, whereas this one was only just the one below. But again, can't emphasize enough, drawing a picture really does help when it comes to tackling questions involving variable acceleration.